As a general rule, we got to see a couple of enchanting pictures as we peer back close to the start of everything. The James Webb Space Telescope has, of late, revealed a divulgence that challenges our understanding. This exposure has satisfied the interest of room experts and specialists, indicating a possibly colossal occasion ready to change the universe from our perspective. The meaning of this finding is basic, bringing requests up concerning the genuine defense for our vast presence. The requesting arises, might this revelation ultimately prompt the farthest reaches of all that we know? Is the universe on the edge of a fundamental occasion past our ongoing discernment? Go along with us as we jump into the latest disclosure from the James Webb Telescope and investigate its true capacity for reshaping how we might interpret the universe. Our undertaking starts with an assessment of the discernible universe, or rather a window into the massive spread past the recognizable universe. It incorporates all that should be visible, estimated, and investigated with our telescopes and space missions. It is a mix of stars, inestimable frameworks, and superb bodies clear to us, indicating a little piece of the entire universe, a little piece of an immense riddle that individuals attempt to survey and manage. Despite our headways, the general size and plan of the universe stay a secret. The breadth of the noticeable universe is assessed to be around 93 billion light-years. This staggering figure results from different parts, including the distance light can go in one Earth year, and the age of the universe, assessed at 13.8, a long time since the huge explosion. This shows that the unmistakable universe extends 13.8 billion light-years toward each path from Earth and has a width of around 93 billion light-years. Nonetheless, Hubble's regulation shows that space has been growing since the enormous detonation, making the noticeable universe moreover extend. Current evaluations propose that items transmitting light billions of years prior, from a distance of 13.8 billion light-years, are presently around 46 billion light-years away. This movement recommends that the detectable universe expands in excess of 46 billion light-years toward each path from Earth. The massive extension, started by a strong blast billions of years prior, has made the universe grow as well as speed up. Complex powers, similar to dim energy, give off an impression of being driving this speed increment, extending the texture of room further separated as the universe grows. Gravitational powers orchestrate particles, accomplishing bewildering developments like stars, worlds, and planets, including our own Earth. Despite the extension of the universe, imaginative sorts of progress have allowed people to investigate a more noteworthy piece of it persistently. Explicit telescopes, including the Hubble Space Telescope and the James Webb Space Telescope, have empowered the perception of far-off stars and designs, making these miracles more available to the overall population. In taking into account the limitless field, it is entrancing to take note of that even inside our nearby area, the universe shows up strangely void. The nearest star, when downsized to the size of a quarter, would in any case associate with 2 soccer fields away. This immensity extends just inside our smooth way, one of billions in the perceivable universe, offering us a short look into the tremendousness of the universe. As we proceed with our evaluation, the new bits of knowledge given by the James Webb Space Telescope add one more layer of importance to how we could decipher the universe, impelling further requests in regards to the idea of our reality and the potential for uncommon occasions for a vast scope. You might be interested about why we can't see the entirety of the universe. There are a few clarifications for this restriction. In spite of light being the quickest substance in the universe, it actually requires investment to cross space. Hence, when we notice far-off objects, we are basically investigating the past. The farther an item is, the more its light has made a trip to contact us, making a sort of grandiose time machine that extends the genuine history of our universe. As we witness systems millions, on the off chance that not billions of light-years away, one more squeezing component at play is the extension of the universe. Envision the external layer of an enlarged inflatable canvas in spots. As the inflatable extends, the dabs move separated, like worlds floating away as the texture of room develops. This extension brings about a peculiarity known as redshift, where the light transmitted by far-off objects goes through an adjustment of frequencies, extending toward longer red frequencies. A few gigantic bodies at last arrive at a basic distance, with their light being excessively far away to contact us because of the consistent development of the universe. Taking into account these two basic parts, the development season of light and the extension of the universe, it's not shocking that we haven't seen the aggregate of the universe yet, even with the most progressive telescopes and innovation. Our vision stays compelled by the essential components of the universe. We ought to dive further into these ideas. The size of the universe is a moving objective, estimated in light years to demonstrate the distance light goes in a year. Our system, the smooth way, navigates around 100,000 light years. For sure, even inside our reality, the closest star to our Sun, Proxima Centauri, is around 4.24 light years away. At the point when we look at space, we can see universes billions or even trillions of light years away, allowing us a concise look into the early history of the universe. The secret of the universe's edge has enamored the interest of individuals from different fields. While explicit clarifications stay slippery, three significant speculations have arisen. The first recommends that the universe is limitless and huge, with no unmistakable endpoint, expanding perpetually. The second proposes a limited universe, without a conclusive edge, similar to an immense circle or contorted space. In this situation, voyaging endlessly toward any path would ultimately restore one to the beginning stage, like circumnavigating the Earth. The third speculation, the multiverse hypothesis, presents the chance of our universe being one among many, each with particular actual regulations and properties. These universes could work freely or be interconnected, molding a tremendous and complex multiverse. Investigating these hypotheses sparkles both logical and philosophical premium. The possibility of an endless universe challenges our impression of room and its boundlessness, while a limited universe without an edge convolutes our contemplations about cutoff points and travel, proposing the potential for rehashing designs inside the texture of room. The multiverse hypothesis, with its equal universes, opens up potential outcomes past our ongoing comprehension, showing spaces altogether unique in relation to our own. In any case, it's significant to take note of that these thoughts stay theoretical and subtle, anticipating further assessment. Investigating the universe's edge presents huge difficulties, making it challenging to approve or invalidate existing speculations. The boundlessness of gigantic space, joined with the constraints of our observational instruments and innovation, makes impediments in disentangling the secrets encompassing as far as possible. In the midst of this tremendous vulnerability, the James Webb Space Telescope arises as a consoling sign, promising to reveal insight into the unpredictable starting points of our universe. The JWST stands apart as a game-evolving gadget, offering unmatched accuracy in noticing the universe. This earth-shattering instrument can possibly uncover the secret history of our universe, giving bits of knowledge a long ways past our creative mind.